fabric onto the table like a tablecloth. I'm going to put a box on here. We'll put a glass bottle on here. I'm going to put 2 cups, 2 lightweight plastic cups on here. But in one of them, I'm going to add some extra weight. So I'm going to put some extra weight in this cup, but not in this cup. Okay. Now, if I grab the tablecloth and I pull slowly, then the friction between the tablecloth and the items provides the force to make the items move, right? So I can make the items move across the table if I pull slowly. If, on the other hand, I pull quickly, then the friction between the tablecloth and the objects, I've reached its upper limit, and that friction can't provide a force large enough to make these objects move at the same rate as the tablecloth. And so if I take the tablecloth and I pull it quickly, I ought to be able to pull it out from under the items. Now, there was still a frictional force there. In fact, you could see that this cup tipped over, right? And this was the cup that had nothing in it. The cup that had the weight in it remained stationary, right? So the heavier an object is, the more mass that it has, the more inertia that it has, the greater its tendency to keep doing what it's doing, right? So if I have something that's really massive, it's difficult to make it move. On the other hand, if it's moving and it's really massive, it's difficult to make it not move. All right, so what I have here is a steel wedge. This is normally used for splitting logs.